Howdy everybody in YouTube land. Well, this video is about yet another Toshiba. This, however, is the T4700 series. So I picked this up on eBay relatively cheap, and the only reason why I did, actually there's two reasons why. Reason one is it has sound. It's the same laptop as my 4600 series, mostly, with the addition of sound hardware. But not only that, the other reason why I picked that up is because I have a pile of new old stock parts. Now, not all of these parts will fit that machine, but these are all the parts I have on hand for the 4700 and 4800 series, which includes the passive matrix models and all this other stuff. So I want to go through these parts eventually to figure out what will fit that machine. Does this machine necessarily need those kind of parts? No, not really. With the exception of the plastics here, because the plastics got busted off in shipping. So we've got damage, and then we've got a little bit of yellowing and stuff like that. But you know what? If I have functional top and bottom plastics for this machine, why not use them? But on top of that, I also have new old stock board sets, power supply board, motherboards for this machine. And you got to think, these are sealed up with desiccant packs. So there's not going to be as much moisture problems as there are from that. And that's the number one killer of electronics, is moisture, right? So we're going to have a whole new board set we can put in there to make this machine essentially new old stock, because why not? We're going to have a new old stock housing potentially, or some of the housing. We're going to have new old stock logic boards, power supply board, which is going to still need capacitors regardless. But, you know, if we have the parts, why not? And I also have this new old stock FL backlight, but I think this is for the CS model, which may not be the same. I have the inverter as well. It should fit in there. I don't know if it's the original. It looks like it's been opened before, so this could be... The thing a lot of service centers would do is they would order in a new part. They'd take the part out and for some reason put the old one back in there and save it. Why, I don't know. To this day, it just doesn't make any sense. But regardless, we have some new old stock parts that we can use to put on this machine. So without further ado, let's get into this machine and see what we have going on. Alright, so this time I have the microphone set up, which unfortunately you can see this charging cable here because these wireless Me devices are extremely finicky. They don't want to charge half the time, and I don't know. Anyway, so I got this thing permanently plugged into the charger, so hopefully that works fine. I see the VU meter on the camera seems to be working, but anyways, we're on a tripod and I have to work around this tripod. So on this side we have the missing door. It's broken completely off because it wasn't packed properly. In fact, I'll insert a picture here that shows what was going on. Yeah, not good. So we've got audio on this thing, which is cool. We still have the rear port door and stuff. This is so commonly broken. That's broken. I had to tape it back on because it was damaged in shipping. And you can hear things flying around inside from broken plastic. We have our mouse port here where the mouse goes. A little ball mouse generally. I think this is kind of done too. Anyways, that hides a PCM CIA slot where it's a single height slot, and then we have a double height slot right here. Unfortunately, the door is missing, and I don't have the original door to be able to model what this was. I might be able to get a picture, but I'm not entirely certain. Anyways, we have our complement of ports here. A little bit of cracking going on there, not surprised. And hear that? Yeah, it's broken. Missing the battery, although I have one. It's just corroded, but I can take care of that. This is the T4800 CT with the 500 meg hard drive. I'm not sure what this does. Not a clue. But also, there's a microphone right there. Yeah, I can see that. You see this? You can kind of tell there's some issues going on here. So, alright. So there's our machine. Yeah. Well, looks like we're missing the little lens cover there. Not a big deal. The screen is in good shape. Every single one of these has leaking capacitors on the board that's in here. Looks like we've got an Energy Star sticker this time around. And the keyboard looks like it has very little key wear. Feels fine, but it's extremely dirty. We got a lot of staining and stuff like that. Other than that, the screen looks like it's in decent shape. There's no vinegar syndrome or anything like that. We just have just a little dirty, but no scratches, no gouges or nothing like that. We have a hard drive caddy in the front. At least in this one, they made the hard drive. You can see someone tried to peel this apart, but you can see on this model here, let me close the lid here for a second. They made the hard drive accessible and removable, because the 4600, there's no way to get to the hard drive unless you tear the thing 100% completely apart, which is not exactly a good thing. So, I mean, you can get around dealing with that, but it's just, you gotta tear it all the way apart. My other concern is, I bet you this has the same belted floppy drive that all the other Toshibas of this vintage did, which means repairing this thing is going to be nearly impossible. I can probably just replace that with a Teac drive, which requires me notching out the plastic a little bit, and then that way the eject button can move over. That's about the only thing I know to do with that. So I don't want to turn this thing on right away, because we've got to check the capacitors in this thing, because these things are made in that era where the capacitors leak. But we got some new old stock parts anyway, so I'm not worried about that. But even then, the new old stock parts needs the capacitors replaced. But honestly, I think this machine would actually make a decent DOS gaming machine, because we have a TFT active matrix display. We've got onboard audio. I just don't know what audio hardware it has. And we've got a 486DX processor, so we should have a very decent performer. Will it run Doom at full speed? Likely not. But you know what we should do once we get this thing running, is we should run the Phil's Computer Lab diagnostic tool set, so we can see what we're dealing with. So, alright, now we just need to get this thing taken apart. So let's get to it. Okay. I don't exactly know how this removes, because I bet, there we go. Okay, we have, what do we have? Oh, we've got a pull tab. That's charismatic of them to do. Proprietary edge connector. Not surprised there. Is this still its, yeah, it's still its original hard disk pack. You know, we should attempt to plug this into the computer, not this one, but like a modern workstation, and see if there's any factory installed software or stuff on this. Because archaeology is kind of the fun part about this too. Let's see, what else is there? There's a little bit of corrosion in there. It's like kind of weird and interesting. Anyways, is this the belted floppy drive? Well, let's see. It looks like it is. Yes, it is. This is the same EME278 drive, which is 1,000,000% useless for anything we can ever do with this machine, unfortunately. So the next question is, how do we get the two halves apart? If I were to guess, now this is just a guess, it's going to have snap clips all the way around, just like the Toshiba T4600C series has. I'm not worried about the screen, but I am worried about, yeah, that's what I thought. We got some snappity doodahs in there. I'm trying to do this without breaking the machine, because I think I have a replacement top cover, but I don't know if it's the exact right one, because these parts in my stash are for the 4700C and 4800C, but there's also some specific parts that don't cross compatibulate between the two models here. Like, I've got the 4700CS parts, and this is a 4800CT, which is pretty self-explanatory because the 4700 is the or CS is the passive matrix display. But oh yeah, I don't like how that sounds. You know what? We need to check the rear too. Yeah, that's what I thought. We've got some screws in the rear we gotta remove. Especially up here, because yeah, this is a different design compared to the, I mean, it's overall similar to the 4600C, but it is not the same. Not by a long shot. So we have to take that into account when we're working on this. And these screws are already loose. They are definitely loose. Now, what I don't know off the top of my head is if the replacement bottom cover comes with these doors. So I am going to remove it so they don't get broken. Because I want that one out of the way, and then I want to take this one off the dot connector, because I need to get in here. I don't think I have any more of these cover doors at all, because it got broken. Now what I would like to do is, it would be cool to kind of like model this in some kind of 3D software so I could just print a new one. Because if I can get something close, I could probably just print a new one, and it's not so much in the way anymore, right? So I can actually make it look decent. Yeah, see that piece of plastic go flying? Yeah, these are, yeah. It's made in that era. This is from like 94. Right before this was like the last model. I think the 4900 was the last model before, yeah, you see that? Just broken. It's like the last model before they switched to the gray series. And every single one of the gray ones were brittle, so. But yeah, this thing's 191840, and that's the exact part number I have. So this is a 191840, and we have a brand new one, which is also a 191840. So we're good there. I've got a brand new one, so I can replace this. So I don't need, I'm not worried about this one. This one's broken anyways, so this can go straight into the garbage. Because it's, yeah. So, in fact, you're going over there. Okay, let's see. What do we have? Ooh, we have a nice, bombastic-tastic green Varta battery here. What in the world? That's not stock, so someone's had this apart before. Not surprised. Well, maybe not. Let's get you out of the way at least. So we don't need you in the way. This is the same keyboard that's in the 45 and 4600 series machines. But this is new. I don't remember this plate. The 4600 does not have this thick aluminum plate. So they've changed the design since then. Alright, so we have a connector there we can remove. We have one here, which is this is probably the inverter cable. And this is the LCD cable, which I have. Okay, so we got to remove the ground cable here. Move you out of the way. Okay, so now to remove the rest of it, we've got to remove the rear screw here. And I'm going to remove the other rear screw down here. And then there's a screw here. Oh yeah, there's the little screws there and there. I want to remove you so this doesn't get bent. And we have our little sensor there. So that is now out of the way. So we can move you aside. And a matter of fact, I hear crap moving around like a screw worked loose. So yeah, that's going to have to come apart. I mean, that has to come apart anyways, but... Okay, so with that removed, what do we have going on here? Here. Microphone. Ah, there we go. There's the battery. Oh, that's great. There's no corrosion, so this thing did not leak all over the place. Get out of my way, little Varda. You're going to have to go away too, because we're going to use as many new old stock parts as we can, right? So we have, looks like you slide out from under there like that. ME2708, yeah, that's what I thought. These drives are, they're a no bueno. Oh yeah, all of these screws are loose. They're terribly loose. So we're gonna move you in here. I don't know what that's about. At this point, I'm just taking screws out. Because quite honestly, I don't know what I'm gonna find. Yeah, it's the exact same type of cable. Which is gonna be fun because when I put the retrofit in there, we're gonna have a ton of extra cable we gotta fold somewhere. And that's gonna be interesting to do with the shield in the way, because on the 4600 there's a big hole here where the hard drive goes. Well, I replaced the hard drive with an SD card solution, which gave me all this extra room to bunch up the cable. Well, I'm not going to have that again. So we're going to have issues with that in general, I think. Plug you. So you're now out of the way. That's the power button. So I would say that's a mighty bit important. And how do we take this thing 100% apart? Okay, you don't need to be in there. You go away. That's the same as the 4600. This should be the same as the 4600. It looks like it is, but it's kind of stuck in there. It doesn't want to move out. Oh yeah, because it's up under this. So that has to be removed first. So we need to figure out exactly how this thing's going to come apart. A lot of these are the same screw. Yeah, it definitely has to come out this way. Remove you. Time to just start taking out screws. That's essentially where we are. Oh, there we go. Intel DX4. What is this one? 75 megahertz. Ooh, that's a little nice. So that is a nice little motherboard. Do I see any of those leak? Yeah, I do. 1, 2. These caps here leak. In fact, actually, you know what? I'm not really seeing any signs of it. Not really. Now that I got the metal shield off, that will come out. Alright. So, now we have that board out. Or that top cover off. How do we remove this board? It should be fairly straightforward because they're in two halves. We have a lower half and we have an upper half. So, okay, here we go. This reveals a lot. So we have this board here, which is the power supply module, where we've got a 1500 at 6.3, but notice it's a low profile capacitor. That is going to be critically important, because we're not gonna have the room, because this has to be sandwiched between here and here. So that height is definitely restricted, because that's where our standoff meets up, which is right there. So we can only have, yeah, this thing is literally touching the bottom of this case, so that's important. Now these are unfortunately the ELNA RCX series, which these leak. Every single one of these leak. So this board has to be redone. Now, I should have a new one of these boards, but we got to set that aside because that one has to be redone. This one here has these types of caps that need to be redone. We've got 1, 2, 3, 4, 5. So we have at least 5 on this board that need to be redone. So we'll set you off to the side. This is the audio hardware, which we have 1, 2, 3, 4, 5, 6, 7 caps on there that need replaced. And that's not going to come out anyways because of this metal shield that has to come out. So my question now is, how do we get this metal shield out of here? Because it does not seem so clear cut. All right, step 1, another screw to remove. So we have you, and this one is not, yeah, this one's missing. There we go. Now we're getting somewhere. Kind of. Alright, it's been extractificated. When in doubt, just pull harder. So, there are, yeah, this one's broke, that one's broke. This whole side broke on me, which I'm not surprised. So, let's move you out of the way. And then, now we have you, which, how do we extract you? Let's see, we got to remove the floppy drive cable, because we have to remove the floppy drive. Because I need to get in here to get to the board stack. So floppy drive cable, looks like the floppy drive is secured rather interesting way. I don't know if a Teac drive's going to fit in here. It might. But anyways, let's continue taking screws out. Same size screws. So these, yeah, this is a fun. Yeah, the whole thing is going to come apart. Oop, it's the same exact cable that the Toshiba T4600C uses for the floppy drive. Well, I guess the good news is technically I can take the floppy cable on the replacement drive and kind of like fold it like a loop here and maybe just kind of jam it in here somewhere. Can't go that way because that's the board-to-board connector, so it makes for an interesting time trying to get all of this figured out. Metal plate. Ooh. Talk about the hardest to get CMOS battery there is in the entire system. Yeah, that's a great place for that, Toshiba. That is an amazing place to put that battery. I absolutely love the decisions that companies make on where to put these things. This tripod is like right in the way. Okay, so at least that's what it takes. Yeah, see, this belt. You know, I could probably make a TPU printed belt now that I actually have a 3D printer. And a belt seems like easy to make in something such as OpenSCAD because all you take is 2 cylinders of a defined height. You do a vine, or not a vine, but a vase style print. Yeah, there we go. Drive has been extracted. And these are all, every single one of these are junk, unfortunately. I've not been able to fix one yet. It looks like this is plugged in using some extractable cables. And actually, no, this is not attached. So these, okay. Ah, that's how that's done. Little metal tabulating things. Alright, that was a royal pain in the butthole, but wow. Let's see, what does that reveal? That reveals, well, that fell off now. What does that reveal? That reveals, well, you got a cap there, all the way on the bottom, so we didn't have a choice but to get it all the way apart. Now we have a little tiny screw there that goes through. Little itty bitty screw. And we have another one right here. That reveals the soundboard, which is held on. So you got to do all of this if you wanted to replace this board. Oh, Toshiba, I swear. Yeah, we got one here. That's a very interesting thought process behind that. Huh. Okay. So we got one that has to be replaced there. We have one that has to be replaced here. So what is the part number of this motherboard? This motherboard is FSXIO2. So we have that. Alright. Set you out of the way. Take the soundboard out. The one thing I don't like about this soundboard is this is an analog devices board. This isn't like an ESS audio drive. This isn't like something of any good quality card. I mean, maybe. This is a 3.3 35 volt. 3.3. These are hundreds at 6, which I have. This is a what? This is a 100 at 6.3 volt. So, no, this is 1,000 at 6.3, which I think I have one of these too. But yeah, this is an AD 1848 KP. Yeah, there's one here too. That one's actually showing signs of leakage. It's the only one I see so far. So this is the FSX S01 soundboard. And they're going to need, yeah, they'll need caps. I don't honestly see any signs of leakage. Does that mean much? Not really, but I don't see it. So you know what I'm inclined to do? I am inclined to just open a box. Let's see, what do we have here? This is a P192870 FMASY2. I don't know what that is. So we're going to find out. You are not the right board. What in the world are you? That is a Intel 486SX. No, that is the incorrect board. I'm going to put you back in there. So that does not belong in here. I don't know what that goes to, but that doesn't go to the 4800. That goes to, I don't know what that goes to, so get that out of the way. That doesn't go to where I need it to go. So let's try you. It's funny how people would FedEx priority overnight. Someone paid to have that part delivered and didn't use it. Let's see. Ooh, that is a power. Okay. So here we go. Minty fresh. Brand spanking new. Never opened. I just opened it for the first time. Oh man, the smell. Here, smell-o-vision, smell that. No, that's amazing. That certainly looks like it to me. Yeah. So, okay. CFX3 BT2. Yeah, it's exactly the same. This is an holder board though. Wow. Alright, well. So we have one. Set you aside. So we got one. Don't need you. Alright, so we have at least one board, new old stock. It's going to get a fresh set of caps, but I got so many boards here. Look at this one. New old stock, baby. (194970). It's so old that the adhesive is failing on the thingy. Let's see, what do we have here? 30-year-old bubble wrap. Oh yeah, that looks very familiar. That looks like a baseboard to me. Yeah, it does. But look at the difference there. It's Y4. Let's see. That is a DX250. Yeah, this is not the right one. This is a DX250. This is a DX275. But that appears to really be the only difference. How about you? I have another new old stock board. Brand new. Ow. Huh, that looks familiar. Move you out of the way because I don't need you. This is a FSXX02, which is a 194980. That certainly looks familiar, don't we? Oh, that looks really familiar. And this one still has the metal. Okay. Yep. F3600. So we do indeed have a new old stock base. Whoa, this one's been... Someone's done some BIOS mods on that one. It's been updated. It's fine. So you know what? We have another new old stock board we can use. So this is a base board. FX Steel 1. Here we go. Soundboard. That big box. Another FedEx priority overnight for the little sound card. So we have another new old stock part. Okay, so we have 2 more parts here that we get to look at. Actually, 3. But let's start with these first. Oh, that's beautiful. That's beautiful. It's a 4700 lid, not a 48. But you know what? It's brand spanking new. And it's got 0 scratches. So I'm half tempted to use it. Because it's still in immaculate condition. Is it the right one? No. Not really. But you know what? You can use it. Set that out of the way. This one's a 191850. Never been opened. Until just now. Oh, that is pretty. Wow, that's pretty. That thing is like brand spanking new. That is beautimous. Look at that. Brand new. Oh, it even comes with a brand new port door. Wow, look at that. Doesn't come with these, unfortunately, but that thing is brand spanking new. No sticker. Wow. Rubber bumpers are intact. Wow, that's I'm sorry, that's just you don't see that much anymore. So we got a new old stock part we can use there. So I'm good there. So we have that. We of course have our new old stock top piece, which I showed earlier. So we have that. So I'll set that out of the way. Let's see what we got here. This is a 195260. Oh, this is another cover. Here we go. 4800 CT. Now we have the right one. So, wow, that is so gorgeous. It's brand spanking new. Never used. I mean, it's like I'm the first one to actually put fingerprints on it since the time it was put into the box. But you know what that means? We've got fresh hinges. We've got fresh plastics for the rear LCD cover. So I call that a win. That's it. That's all we have in parts here. I'm going to go through the power supply. Not this one. This one's good. I'm going to go through the power supply board and make sure I have the right one. Because I've got like 3 of these, but there are differences. So I need to make sure I have the right one before I just start substituting a power supply in there to replace that one. Because, yeah. Anyways, unfortunately we do not have a new old stock one of those. Nah, that's okay. But we do have a new old stock baseboard, we have a new old stock power supply, and we have a new old stock soundboard, which are going to get the preferential capacitor treatment. One thing I wanted to say is, so I did a quick look at the spreadsheet. So this is the 201 080 or 060, which is the PS2 power supply board, which is the upgraded version. So that's the right one. Well, it's the upgraded version. This is the 180, which is the PS1, which this is the version it's supposed to have, which is probably what that one is. So if that's the case, that means this one is a better, more upgraded version. Revision 2, this is revision 1. This might actually be revision 2, but I can't tell directly on the board. There's no marking. Point is, we're just going to use this one. So we now have all three of these boards, new old stock, right here. And this is what I mean. I have to work around the tripod. It's not fun. The curiosity got the better of me, so I wanted to check something here. So I'm comparing the two boards side by side, and besides just these style of chips, the boards look identical. They look almost exactly the same. I mean, we've got some components here which doesn't exist there, but other than that, it's exactly the same. Even the north bridge is the same between the two. But the big key difference I see here, this has a DX2 at 50, while this is a DX4 at 75. So my immediate thought is, well, perhaps you could swap this DX2 out with a DX4. Yeah. Run it up to 100 megahertz, get a DX4 100. But I'm trying to figure out how the clock speed is set, because we have this ICS 2023 ASC chip, which I cannot find a data sheet on anywhere. But judging by the crystal, I'm sure this is the oscillator that runs the 486 CPU. So if I flip the boards over and I take a look on the bottom of the boards, they're essentially identical. But what I wanted to zero down into, which unfortunately is inconclusive, is we've got some differences between here and here. So perhaps maybe there's something there. I don't think so. But more importantly, we actually have down here where the clock oscillator is, on this board we have these little jumper wires. So I looked at those, and I'm figuring, well, maybe between here it's going to be different over here. Well, unfortunately, it's not. It's the same. I was hoping the position would be in a different spot, because if it was, then I could move those jumpers around and change the clock speed of that 486. But unfortunately, that is not the case here. So it won't be quite as straightforward to upclock that 486, because it would be so cool to throw a DX4 100 in there and just change the clock settings and run this sucker at 100 megahertz. That would be like the fastest 486 in a laptop I've seen anyways. But, well, that's not going to happen in this video, unfortunately. Alright, so now that I have the boards laid out so we can get ready to recap them, this is the new old stock power supply, so we have that. We got to put some caps in. And this is a new old stock soundboard, which we've also got to put caps in. Now, I did some quick research on the subject, and from what I understand, these analog devices, sound cards, they work, and they do Sound Blaster emulation through, what's it called, the Windows driver model, or Windows Sound, something like that. It uses the Windows Sound subsystem to make it work, so you have to use a DOS driver that gives it Sound Blaster emulation, right? So it works in games, most games, not all, and you get some Sound Blaster emulation, but the one thing it lacks is it does not have an OPL chip. So the OPL chip is kind of what makes or breaks DOS gaming, right? So this sound card, from what I understand, is pretty poor reviews, and it's kind of a limiting factor of this machine. And that's when it was brought up to me that a friend of mine said, hey, the 4800 or the 4900 has a exact same sound card, but it has an OPL chip. So I went through my spreadsheet inventory, and what I found was a 198960, which, if I am not mistaken, is a 4900 sound card. I think. So let's find out. No old stock. Yeah, sure enough. Look at this. It's the exact same connector, exact same form factor. So in theory they should be interchangeable. Except the one notable difference is we also have the same sound chip as this one. This is a 1848. So the driver should work with it. However, this one, I mean, we have the same caps we need to attend to. So I'm going to peel you off so we can figure that out later. But look at this. We have a Yamaha OPL chip. I don't know if this is the OPL2, OPL3, whatever, but we have an OPL chip. So that means we will have proper MIDI support with this board. So we're going to have a Toshiba 4800 that's going to have a 4900 sound card. I just got to throw some caps in it. Soundboard with a nice actual OPL Yamaha chip, which will make this machine desirable. So we will put that in there. The next immediate problem we're going to have is these capacitors. So these caps that are inside here are a high value. So the one behind here is a 5600 microfarad at 6.3 volt, which I do not have. So I'm on the internet trying to spec them out, and the thing is, you got to take a note here, is look at the clearance height. It's very low. So I can get roughly 18 millimeters in here because this cap is 17 millimeters tall. So I can get roughly 18 millimeters in here. I cannot get any higher than that. But this is a 5600, it's 6.3 volt. Which unfortunately I cannot get them. The highest or the smallest I can get is a length of 20 millimeter, which is too tall. The only one that I can get even remotely in the right height is a 4700 microfarad, which is not, it's not good. I don't know what I'm going to be able to do about that, because again, I do not have the height clearance. So I could have a 4700 and maybe a 1000 next to that, because I do have a little bit of space here. But again, how do we get the leads in there? Because I'd have to tie the two together, which means it's going to sit up higher. So that's not going to work. So I'm going to have to settle with a 4700. Unfortunately, because these leak. We can't just use that, because these particular caps are no longer made. They're not made in this dimension. This was a specialized cap, and you cannot get them anymore. So we're gonna have to compromise. Whether it works properly or not is to be determined. These other ones here, like this one is a 2200 at 6.3. I can probably get that, and I know I can get those. These are 1000s at 25, and I know I can get them in that height because I have before. I've actually got them in smaller heights. It's this one that I'm having a serious problem with. And we also have another situation over here with the soundboard, because this one is the same thing. It's 1000 microfarad, but look how short it is. I've got to look and see if I can get those too. But these RSX series here, or RCX series, these are all low ESR. That's why they leak. All right, so all of these boards are completely recapped now. Again, as before, we can only put a 4700 microfarad 6.3 volt cap in here. So original's 56, but the original cannot be used because it is completely screwed and leaking. All of these caps are leaking, by the way. Most of these little fake type electrolytic tantalum capacitors were not leaking, but all of the through hole ones and the surface mount ones definitely were. So those are done. Now we need to move on to the LCD display and inspect that, which I already know the LCD is going to need caps because it's the same panel that's in the 4600 and they all needed caps. So let's get that apart and see what we're dealing with there. And yeah. All right, so the issue with this one is actually there's multiple issues with this one. One, there's something loose in there. And two, there's some micro cracks and all this other stuff, which fortunately we have a new old stock rear cover, so that doesn't matter. First things first though, God, these things are loose. We got to get this thing apart. And to do that, we've got to remove these little rubber grommet thingies, which I'm surprised they haven't melted, because most of the time these things are melting now. Yeah, so we gotta remove that. Which will expose two screws here. Oh yeah, those screws are loose. And it makes sense because this thing is notorious. When you open and close a screen, right, it flexes everything in this screen with torsional forces, which will work all the screws and stuff loose with enough times. Alright, so once those are out of the way, the next thing we got to do is pop all the clips, which looks like a lot of these are already starting to go. And then when you start getting close to the end here, you gotta pull the latch back and run it through the case here. I wish I had a new front cover too, but I do not. I only have the rear. Sniffing for vinegar, signs of vinegar, because I've had these displays go vinegar when they look fine, but you can smell it. And not much longer after that, you start seeing the signs. Fortunately, this is an active matrix display, so vinegar syndrome is readily repairable on these. Unlike a passive matrix. A passive matrix, you have a problem with getting the retardation film. It's the retarder layer that's designed to optically change the wavelength a little bit. I don't know the math behind it, but it's important for passive displays to maintain the right contrast and color. Which is not something I can do with these. Which I don't have a problem with because it's active. Alright, so now we're... Oh yeah, this has been apart before. And here's what I mean by that. One, we have this miscellaneous screw that's loose in here. So that's a problem. The other thing too is there is a screw in here. It's supposed to be through the panel and not whatever that is. So that's not going to work. So we got to get this panel out of here. Easily enough done, we can just remove all the screws. There's 4 screws that go all the way around through the panel into the parameter, so they all come out. And then there's one over here which this is very loose. In fact, this one's backed halfway out. Look at that. This is barely hanging in there. So there's nothing left on that. And then remember, we're replacing this rear cover, so I'm going to take all this out. Because none of this matters anymore. Hinge, goodbye. Okay, so pull you out like that. So we flip this around, which will expose these rear connect. Look at all the fingerprints. This has been out before. That has me concerned. So what is going on with this panel? Remember this. I mean, I have another one of these panels, but it's got vinegar syndrome. So, no, I don't smell vinegar. Alright, so, and this one's all nice and clean anyways. So, we'll set that aside. Oh, I found out where the other screw goes. It came out of here. Alright, so this inverter, I have one of these new old stock. Now, regardless new old stock or not, they're all going to have the same problem. And that is leaking capacitors. 6835, 22 at 35, which I have. Now, that one doesn't have leaking capacitors that I can visibly see. Looks like it's a TL1451 Wonder Muffin. These are very common. Alright, so we'll set that aside. And then that right here is no longer necessary. Yeah, you can see it. It's just cracked right there. You can see right through it. Gone. Alright, well, makes sense because this cracks often because the way these hinges work is there's a load distribution. Because right now that's going through and on the base unit, but we got a screw tie point here and here. So if this backs out, what will happen is it will put too much stress over here, which is exactly what's happened. So this is handling the entire load of moving the LCD up and down instead of both of them equally, and it causes a stress fracture right here. So you got to make sure that all of these screws are really tight. In the perfect world, you'd have Loctite on these screws. This doesn't have it. And I don't have any, so I'm not going to be able to do that. But this is not the important thing. I'll deal with that later. The important thing right now is you, which, before I go any further, I need to take you apart. Actually, no, I don't. This is what we need to look at right here, because what happens here is there are, once again, capacitors that go in here and leak. Surprised I don't see. Normally these screws are extremely corroded, and I don't see that here. Out of the way. No, I don't see that. Generally, up under this board, yeah, normally this thing is eaten out, and in this case it's not. So this one actually might be alright. But the most important board right here is this one, because this board has the timing components for the panel, drives the panel. And these have capacitors on it that leak all over the place. So what we want to do is take a look inside here and see the state of that situation. Be very careful lifting this out, because the problem is this cable does not have much flex to it. I have to be very careful like that, getting it out. Alright, no. Normally this is rotting away and rusted, and I don't see that. Oh, this is a completely different design. Wow. Okay. Normally there's two big capacitors sitting right there. Oh, this is a different panel. So 4800 is using a different panel. Or a different revision of the panel anyways. Alright, let me do another sniff test. I don't smell anything, so I think we're okay. 3325, 4.735. Oh yeah, those are leaking. I can definitely see that. You can see how the solder joint is really corroded right there. So it's definitely leaking. But other than that, you can kind of see it coming through that via right there, which comes up the board right there. So the cap goo definitely got, oh, I smell that. Ooh, yeah. Alright, well, set you out of the way, because I don't want it getting damaged. So the next thing I want to do is take a reference photo to make sure I know where they all go. Okay. And that's it. We're going to recap this thing. Well, it's far from ideal because I do not have these two specific capacitors on hand, and because of the height restrictions, I had to fold them over. But they're in there because I've got 4.7s, but not in 35 volt, only 25 and 16. Same thing here. I only have 25 and 16, not 35. 35 is not something I see common in something like this, but I had this one, so all three of those are replaced. Slightly different design than what I'm used to, because I'm used to having like 3 capacitors here, 1 over here, and like 2 over here, which this one doesn't have these two 33s up here. So anyways, that's done, so I'm going to start getting that back together. The only thing I have to do now is get the caps changed on the inverter, which fortunately I did order them. once again, this is embarrassing. So not only do I have the 10 microfarad at 35 volt SMD, which would have went on the other board, I don't have the 22 microfarad at 35 volts. I got 22s at 25, but not 35. It's these 35 volt caps that are getting me because they're just not common in some of the circuits I work on. So I have to order them. However, meantime, I just took two 47s and put them in series, which gets close to 22. So that'll work. I did have this one, but thinking that, oh, I'm going to have that one on hand. No, not really. So, unfortunately, that's what we got. Now, this was still in the box. I thought it was new. No, it's not. It's actually used. You can see a mark. So, I don't know if this inverter is actually any good. We're going to find out. Before I just go ahead and just put it all back together and say, hey, it's going to work fine. I know better than that. So, I think what I want to do is loosely reassemble the base unit here with the boards and just connect the LCD in and all of that stuff and do a quick power on test first to make sure it posts before I put this thing all the way back together. So I'm going to assemble this thing loosely, I think, and just do it that way. Now, I did make one mistake. That might be a bit important. It's not going to run very well without that. Generally. Yeah. Whoops, my bad. So I've got to get this back apart and, yeah. I think we should be assembled enough to try to fire this thing up. There's no hard drive or anything in it right now. Also, out of that cache of parts, I got a new old stock AC adapter. Now, something happened with this cable. I don't know, but new old stock. I've already taken the liberty of taking it apart and recapping it. And I did that before I even owned this machine because I got this and I was going to use that with my 4600, but it's different. So I didn't. However, this is the correct one for this machine. So that's the one we're going to use for this one. So we're going to just unmangle you right now. Sorry, I'm kind of freehanding the camera at the moment. So we're just going to plug you in there. We're going to get you in there. And we got to assemble. So here we go. Power on. Question is it working? I don't know. Let me turn the light off. It is. Wow, it works. Although, unfortunately, the LCD is junk. Darn, that sucks. That really, really sucks. Oh well. The machine runs though, and the inverter that I had in that box was good, so I mean, we're working. I've got to replace the panel. That is unfortunate. But that is where we are. Well, unfortunately, that panel's got screen cancer. It's what they call screen cancer. That's what those splotches are. So the panel itself is shot. There's nothing I can do about that. The backlight's really strong on this one, though. So that's actually really, really good. So, anyways, we're going to unplug that. We're going to leave that alone. Now, my one saving grace here is I have another one of these panels. It's older for the 4600 that has vinegar syndrome. It's a working panel. But this is a different revision. This is a newer panel, so I can't really use it. So, on that tangent, I'm pretty sure, because I've used this panel in an older one, but I don't think you can go the other way. Anyways, so fast forward, actually rewind. I went to VCF East 2024, and a friend of mine gave me this one. Now, this one, unfortunately, is missing everything. It's the same exact machine. It's same exact machine, but it's basically missing everything. It's beat up. We've got busted plastics. We've got a missing hard drive caddy here. We're missing the battery. We're missing, the floppy drive. The plastic's cracked there. It's all yellow. We're missing all this stuff here. It's just, and we got like rust and all this other stuff here. We're missing a plastic piece there. Overall, it's in rough condition. This thing is basically a parts machine, right? But the good news is the screen itself is intact. So I can take this LCD and reuse it. And then again, we're missing a little plastic cover here. And this thing is just, it's like it's been underwater. You can see the little crap right here. Let's see. Where am I? There we are. See that crap right there where it looks like it's been underwater. It's rough. It's very rough. Keyboard's completely yellowed, which the camera's trying to compensate with it. So this is a parts machine. So that's a whole lot of words to tell you that it's a parts machine. So what I'm going to do is I'm going to steal the LCD panel off of this one. I'll probably just swap the board that I just recapped off of this one and put it onto this panel, and I'll see what it does. Now, this was used as a server for years, apparently. So that backlight is probably going to be pretty baked. If that's the case, I can put this panel onto that backlight assembly and make one good LCD out of the two and then scrap this guy. So, yeah, I think that's what we're going to do, because this thing's just, it's beyond saving. It ain't worth 2 pennies. Anyway, so that's what we're going to do. We're just going to do that. I will warn you, the only way to get these panels out is to free this bezel, of course. But you can't free that bezel unless you take this whole palm rest off. So you got to take this thing all the way apart just to get the LCD panel out. So, FYI. But yeah, she's got some crap in there too. It's kind of rough. So, but also another thing I wanted to point out as well is this is another kind of indicator on how these are stored and how many hours is on it. Like this inverter here, if you look very carefully, I'll zoom in, you'll see leakage on that capacitor. Whereas the inverter that I just recapped, there's no leakage on that capacitor. And the inverter that was in here was the same way, if I recall. So just something to keep in mind. Wow, that looks brand spanking new. That is cool. So what I'm curious about, will that fit this panel? Because I don't know. It might. Actually, no, it won't. No, it's different. Crap. This must have been for like the passive matrix display or something. Yeah. Ah, well. I was trying to build a machine out of new old stock parts, but I guess that is not going to happen with this one. Well, some of the parts are new old stock, but this is a 194950, which is not the right one. Ah, well. Alright, here we go again. Let's see what happens. Let's get our plug plugged in here. Plug you in there. And power it on. We are on. Let's unplug the light. Well, that one certainly looks a lot better. We don't have any screen cancer. But also, that backlight is a lot dimmer. It's hard to see in the camera, but it is. And actually, this one might be starting to suffer vinegar syndrome. You see the halo effect around the outside? That's not normal. Then again, that could be the backlight assembly too. Because like I said, this thing has seen a ton of use. So I wonder. Otherwise, the picture quality is great. I mean, it's fine. So I tell you, you know what I'm going to do? I'm heavily contemplating it. Is swap the backlight out. Why not? Let's do it. Alright, here we go. This is the original backlight, and you can tell, you can see the yellow border around it, so that thing's done. Alright, swap the backlight. Let's go ahead and turn you back on. Alright, so we have power. Let's see. Do we have backlight? Yes, we do! Wow, that looks so much better. It's not, there's no yellow halo around it. I mean, there's still a little bit of a halo, but not yellowed. Now, this halo could just be the slow onset of vinegar syndrome. I mean, that's the inevitable death of all these LCDs is vinegar syndrome. But on an active matrix display, you're okay because you can fix those. It's the passive matrix ones you're going to have a problem with. But anyways, wow, that actually works really well. It's brighter too. I bet you with the light on, directly blowing on it with the light photons, you can still see the text. Barely, but yes, you can. It's also in low power mode too, so yeah, there we go. It's all good. So what can we do now? I know, we can start putting it back together. But we're going to have a problem because remember, we have to deal with this whole floppy drive madness. So what I'm going to do is I'm going to grab the Teac drive and see if it fits this case. And the good news is, because we have the original bottom cover that I don't care about, we can experiment with this guy to see how much of this we need to notch off to get the Teac drive to fit. Just for the fun effect, I took the lamp off. We're going to do this right here. Look at that. You can see the halo around the outer parameter. for just yellowed. It's hard to tell with the light blindness, but it's definitely shot. So, yep, that's done. You can kind of see the yellow tinging on the side there. It's probably UV or who knows. I bet you could retrobrite this and get it back. But I don't know. That might be something we can experiment with. Maybe. I don't know. I just figured it out. New fear unlocked. It's the adhesive that goes yellow. Look at that. It's not the plastic itself, it's the adhesive. Let me zoom in. It's kind of hard to focus on it, but yeah, it's the adhesive. The tape strips that line down it. So I bet if the tape strips were removed, this thing would be fine. Because otherwise the plastic is okay. It's just the, yeah. Next logical step, since that now we know everything is working with the display and all of that stuff, let's just go ahead and get the display put back together. Big thing for me is to get that done and out of the way. And then before I put this back together, we need to make sure that we've done every possible thing that we can think of on the inside of this thing before we snap it back together. Because when you snap on all those top and bottom covers, if you need to take it apart again, chances are extremely high that you'll break the clips surrounding the palm rest, because I've broke them every single time. Even when using a spudger tool, I can't. You be as careful as you can. It's just the plastic is just a little bit brittle and it's starting to snap apart. Not a big deal. I just need to make sure that this thing is 100% wrapped up before I snap it all together. But before we can do that, we've got to figure out this Teac drive situation. I know they hit a battery down here, but this is a rechargeable lithium. It's probably no good anymore. Honestly, I don't really care about it. I don't care if it holds the time or anything like that. None of that matters, really. But the one good thing that it does do is it does hold enough of a charge that if you power it off real quick and plug it in, it'll still maintain its settings. You don't lose all of that. But honestly, at the end of the day, I don't care about that battery. So I'm going to leave it alone. It's at the bottom of the system anyways, and it'll be out of the way of everything else if something happens to it. Bad idea, I know. But I don't have the tools to weld new terminals on a replacement and do all of that. I don't care about that battery. However, the big standby barrel battery, which is that green one right there, will not go back in here. It will remain out of the unit. So, we'll experiment with that in a bit. For now, I need to get this thing put back together. So that's what we're going to do. That came out really well. Besides a few little scuffs on the actual front bezel, this thing looks amazing now, especially with the new old stock rear cover. Wow, that looks good. Thing's gonna look brand new when it's all done. So now this thing is a new old stock Teac drive. Like, this thing is brand spanking new. Never used. The problem's gonna be, though, will this fit in here and will it work properly? Still has a piece of tape on it. So what we need to figure out, once I get the tape off this drive, is will this thing actually work? Now, unfortunately, these drives, depending on when it was made, some of these have an electrolytic capacitor that needs replaced. Some of them use tantalum, depending on when it was made. Now, this eject button is very thin. That's going to have to get painted. But the more important thing is, what I need to find out is, do these screws line up? So, what do we have here? We've got, oh, well, looks like it does. Well, that's going to have to come back off. But, you know, let's see, let's check the other side. Oh yeah, look at that. They line up perfect. Alright, so that lines up, but does it give it any room to work with the ribbon cable? Because the issue we're going to have is, unlike the T4600, this is all blocked off. Where before, on the app, that one, the hard drive was, you know, permanent, so you could roll the cable up and shove it in there. This one, not so much. It looks like this particular, oh man, this is going to be fun, because there's a notch out that goes through here, so there's only that much room for a cable to fit in there. That might be problematic. For testing purposes, I'm going to just get a cable rigged up in here. Once again, we're just going to hook the display up and just temporarily plug stuff in here to make sure I can boot from the floppy drive before I start drilling the case and all this other stuff, because it may not go back together. And wow, that thing, it's been sitting in that box for so long, for so many years, that tab got bent. It's pretty bad, actually. Yeah. But no, unfortunately, this is not, you know, white. I need something that's beige or white, so I'm going to have to paint that. And now the paint that I have is a little bit brighter than the original color, which is here. So we're going to have to just deal with that. But yes, it looks like it will fit. However, they, in their infinite wisdom, they, as in the manufacturer of this drive, decided to just put a shield here. So we're going to have to take the shield off, because here's the other thing I need to express. The Toshiba, it's not even, the Toshiba computer, but the Teac what is this? This is the FD-05 HG. This machine has a ready signal, and it has a density signal that these newer, more modern drives do not use. And if you plug a cable in there as is without cutting the trace or whatever, you're going to get stuck in 720K mode. It's not going to work. And the ready signal needs to be pulled high or low, or I forget, something like that, which is easily done. I can do all of that. But the most important thing for me right now is checking if this drive has a capacitor on the logic board, because without that it does not work. Okay. So there's generally, it looks like it does have an electrolytic there. You can see it right there, hiding out. Holy, okay, not a big deal. I just got to get it out of there. Okay, it looks like we're going to have to take the top cover off too to unplug the head cables. JIS screw. And this is not a JIS screwdriver. Alright, so we have you. Very weird rub pattern. Okay. So to get this board out, we have to unplug three things. We have to unplug the stepper cable. To unplug both head cables here and here, which will allow that board to drop out like so. And there's the nasty little capacitor that has to be replaced. Yes, looks like it uses the same chip that every other Teac FD-05 uses. Now, this is the connector that has the signal on it that we've got to bypass. And the way we're going to do that is, instead of cutting the trace, I think you can remove a solder blob. I gotta pull up my reference photos because I took pictures when I worked on the 4600. So I'll undo that, and then there's a jumper that I gotta install for the ready signal. And I think that's it. Careful, this is the track 0 sensor. So, alright, you know what? I think this this thing actually might have... What the hell? It doesn't... Anyways, we'll take care of that. Yeah, we're going to have a lot of fun with this ribbon cable because it's so long and it's wide, so that, because the original starts wide and it shrinks down, and they molded the case to that. So yeah, anyways, this is just temporary until I can figure out if this drive is going to work properly. Let's see, here we go. There we go. The Teac drive is working. There we go. So now I feel safe modifying the case. Nice. And as before, pin 13 has got to be disconnected from the circuit or it will not work. Everything else is left alone. Yeah, that's not going to have crosstalk at all. Not at all. It's going to work perfectly fine. Right? Right? Is it? I hope. God, I hope. So in an effort to keep things simple, and I don't want to Dremel the case out for the floppy drive like I did on the 4600C, I'm actually using my 3D printer this time around. So what we're doing is we're printing a new eject button, which, by the way, I'm doing the highest quality print just to see if it's going to fit and work right. So what I've done here is I've designed this little guy in Tinkercad, which should just be a very square replica of this. because I want to make sure it fits first. This, I tried to paint it and it came out terribly. So I'm going to do this first, make sure that this fits, and when it does, I think what I'm going to try to do is just come out with the eject button, because the problem is this button is too far over to the right. It needs to be over a tiny bit, but then this is going to get in the way. So what I'm going to do is just make the button come out and then go to the right like a L-shaped button, but then I got to create a little hollow spot in here to make room for this. I think that'll work, but we'll see. Something kind of like that. So that offsets the eject button. So in theory, yeah, it's not too much of an undue torsional stress. We're good. So I ran one more revision, and that is pretty centered. I'm not going to get it any better than that. 3D printing is a godsend because it makes this possible. So the good news is I was able to get this cable folded up and up underneath here and plugged in, and I got the screws in. Now, the drive screws are the different size. So I still had some of these little tiny ones right there that were left over from the parts display that I used because it's that thread pitch. Those are the right screws. And also, because this drive is thinner than the original, there's enough space between this plate and the drive itself to hide the cable. So that certainly helps. So what I'm going to do is just fold this cable a little bit tighter and harder. That way it's not pushing down on the case as hard. But it will fit directly under there. And this is how I had to fold it. Basically turned it into origami. Now, in a perfect world, you could probably go to, like on a PCB way or something, or KiCad or whatever, make a new cable that reduces down and goes big again, and just run it through JLC or PCB ways, flat flex service or whatever. I'm sure you could do that, but I'm not going to, because this is just easier. Path of least resistance. No, I wouldn't say easier, just path of least resistance in this case. So there we go. The floppy drive door is painted. I had to leave it sit because it's the winter time and it doesn't really want to cure. But that should be good to go. So I can just take you, put you in there. And there we go. And that's it. That will work fine. As I said earlier, this machine here, this is the parts machine, is missing a whole bunch of stuff. So I'm going to part this one out and use that anything else to fix this one good one, and then the rest of it's just going to be whatever. I'll probably save the boards just to have them. Other than that, I don't really care a whole lot. In the meantime, though, it's time to start reassembling. sorry, the camera died on that one. Anyways, one thing I wanted to go over with real quick during the reassembly process is these hinges are new old stock along with the rear cover. And one thing I want to indicate on what hinges should feel like is this right here. Like this thing is there, it's so soft it'll fall under its own weight. That's the way it's supposed to be. Now, it's hard, but it's soft and smooth at the same time. It's hard to really express other than that. See that? It's like loose, but also not so loose where it can't hold up under its own weight. I don't know the best way to put that into words, but that's how these hinges are, and that's the way they should be. And I've noticed with a lot of these machines, actually all of these machines I've gotten, they're much more stiff. And I think what happens is, if we look carefully here, there's grease packed in here, but notice how clean that grease is because they're new old stock. So what I think happens is this grease gets packed with dirt from use over the years, and it gets it more abrasive and gritty, so it gets harder and harder to move. And that's what results in the stress fractures in the plastic and all of that, because the torsional load is much higher than it should be. Anyways, so we've got, I didn't get it on camera, but I had to fight with this. This actually goes up under the shield. I forgot about that. It goes up under the shield, and screws go in. We're all good there, and the screw goes in here. So I got that in there. I had to bend over and put in the display cables and all of that. I didn't get that on camera because, again, the battery died in the camera as I was filming the time lapse. The other thing I want to do too is I'm going to hook the keyboard up, and I do not want to put the top cover on until I know 100% that we're good to go. So I'm going to just put the keyboard in and just gently set it on here and leave everything alone so we can test it, make sure the hard drive works, check boot up, I want to make sure that the audio hardware is compatible that I stuck in here and all of that fun stuff. So let's get everything connected here. Here we go. First power up. See what we get here. That does not sound good. That sounds really, really bad. Oh, yeah. I think that drive is done. Question is, does it work? That's a really good question. Check system F1 key. I don't know why it's doing that. Probably complaining about the hard drive. That hard drive does not sound good at all. No. The question is it accessible? It is. Wow. This thing was used as late as 96. I don't think any of the original software is on here. Alright, just because of how bad this thing sounds, yeah, there's some Toshiba utilities in here. So because of how bad this thing sounds, I am going to back up this hard drive first before I start this thing up, because I don't like the way it sounds. Alright, so we're just going to back this guy up. So, well, actually it's showing this hard drive is a 2 gigabyte drive. Yeah, that's weird, but okay. supposed to be a 500 meg drive. Huh. We'll go with that. Yeah, I didn't think so. It is not a 2.1 gig drive. There's no way. So it appears that modern devices just cannot detect the capacity of these older drives. And I've run into this before, but so we're going to have to put this back in here and then use my disk to start this thing up and image the drive onto like a zip drive or something just to fix this mess. Try to back, because I need to back up the tools on this drive without losing the contents on the drive, because I don't know if the 4800 CT software can be found. I really don't know. So I don't want to take any chances. So to give a little insight on what I'm doing here, I've got a boot floppy which contains DOS 6.22, contains the System Soft Card Soft drivers, which also has the ATA driver, and I got a copy of this Norton Disk Editor, which will let me copy the raw sectors into a file so I don't lose anything. Okay? Now, the problem is, for some strange reason, the CardSoft driver will only format like 300 megabytes or so on these flash cards. Now, unfortunately, I tried it. It does not work with these SD card adapters. It will sometimes, and then you go to format it, it'll show that it's there. If you reboot, the file system's lost. It won't see it again. It'll come up with a different cylinder count every single time, because the CardSoft driver is designed to work with physical hard drives in here and not actual solid state cards, which are logically addressed. So that's just the thing to watch out for. I have a 4 gigabyte compact flash card in there that's an old one, and it will format, again, it only formats it to about 300 megabytes. So what I have to do is I have to take the hard drive and break it up into chunks. But that's the best way I know how to make this actually work, unless I had a network interface and I was doing it that way. But there's only so much you can fit on a bootable floppy. Also, seems like every time I take these apart, the clips always break, and I can see why. This clip here is right up against this metal inner magnesium frame, so there's nowhere for it to go. So when you try to get the lid off, it's just going to snap this off every time. It always snaps up here too, but if you look very carefully, look how thin that plastic is. So that will always snap off, and that's why. And there's no way to anchor it anywhere but that clip. This one will snap off sometimes, but not always. This one is almost a given, and that's how you can tell when these things have been apart before. So that's why I wanted to make sure that everything is good before I snap it together. There it goes. I only got the first 88%. So that's like 1/3 of the drive to almost 1/2. And she died. That's unfortunate. It is what it is. But hey, I got some of the data. Is the end of that drive. I can retry it, but nah, she's done. Alrighty then. Well, we're just going to give up that avenue and we're going to move on. Hopefully we have enough of the data to where I can get some of the files back, but I don't know. We'll see. Fortunately, the software froze, so I just pulled the drive. That scares me because I'm hoping it didn't corrupt the file that's on the compact flash, because if then I lose it all, it's all gone. It's all in vain. And that's exactly what happened. It's gone. There is some good news. It did save the image before the SD card took a dump, which has my 393 megabyte fat volume on it. And inside that is my... It recovered 200 megabytes out of the 500 meg drive. So now I just copied that over and renamed it. Let's see if it will open that. 500 meg, but it's going to be screwed. Yeah, we're going to need to run a recovery on that one. Oh well. It's browsable in UFS Explorer. So I don't know how much of this is going to be viewable. Oh my god, this was an engine computer. PCM, dyno. Wow. Cam shop. I'm gonna say, well, that's empty, so it didn't get dumped. That one's kind of there. Let's see. It would be under Toshiba. Yeah, that's gone. Util. 48 demo. I mean, there's some stuff in here. I don't know. Yeah. This is, unfortunately, PCM Plus. I don't know what that is. Old Dyno. I mean, some of it's still in here. So, I mean, I didn't do too bad, I guess. But the drive did die. Oh, wow. It's got After Dark. Oh, I didn't know they made After Dark for Windows, but here we go. Yeah, I got some of it. Well, unfortunately, that hard drive did not work out at all, which we knew it was not long for the world because of how it was sounding. But I was able to recover some data off of it. Not really anything useful. It had a full-blown copy of Windows 95 on it. I figured that out. But I got some of the files. Nothing that I can actually use to set this machine up, though. The original owner, whoever owned it before me, deleted all the restore files and all that stuff. That stuff's gone. So, anyways, so we're going to move right along here. We have yet another new old stock item. Now, this is a new old stock 810 megabyte hard disk drive. So we are going to install this guy. It looks like that one was shipped 25th July of 98. And there we go. That looks so cool. It's brand spanking new. So that is what we're going to install. Now, this one is not as thick as the original. What I need to find out is if the screws are in the same position. Don't think that they are, but so cool. Brand new. So we're going to install that one. Who knows? That one may not be any better. But, you know what, though? It's cool. Let's do it. Alright, so here we go. That's better. Few gentle love taps. Because the drive hasn't been used, well, ever. It sat for 30 years. So, okay, now I just got to get a DOS disk in there and get everything set up properly. Which I'm going to skip ahead and do all of that off camera. Sacrilege. So I decided to go with Windows 95 so I don't have to fight with drivers and all of that, at least for testing. Because I want to make sure that the audio hardware works, that the MIDI works on the audio hardware, and all the various things like that. Once I know everything is good, then I can get this thing back together. And we can do some DOS benchmarks and other little fun things like that. So besides the hard drive issue and the MIDI issue and all that stuff, I ran into another problem. I could not get this thing to read a 720K disc. And I've run into this before. And I forgot how to fix that. So I want to document this for anyone else with this problem. So I did fix it. It'll read 720 and 1.4 meg discs. And this is how it's done. Pin 11 also has to be disconnected from the floppy drive. Not just pin 13, but also pin 11. So that is how we make that work. Now, I still have a problem with the OPL setup. I don't know what's going on with it. I wonder if there's a secondary I/O part or I/O port for the MIDI. The BIOS is not, compensating for. It doesn't realize it's there, so Windows doesn't know that there's something there. Now, I could probably try a DOS driver, which might have the MIDI driver. I'll have to look around and see. I'll have to play around with that. I tried to find as many utilities as I could, and getting drivers for this machine is actually kind of difficult. I cannot find the audio hard drive or audio hardware driver anywhere for DOS. I only found the Windows 3.1 driver, and there's no DOS driver there. And I found some forum discussions that go into detail about people looking for the same thing, but not really finding anything. So I just went ahead and put this thing back together. I left the sound card alone. One thing I want to point out though is look at this. See this flickering? I noticed that with this panel. It's almost like they're scanning this in a successive way to generate the proper color blending. It's kind of weird how that works. I also found some Toshiba utilities for Windows 95, and I don't see any MIDI definitions in there. Also, I found screenshots of the 4900 BIOS. It's no different than this one. There's nothing that indicate turning on or off MIDI or anything like that. I did try to install the AdLib driver, but when you try to play MIDI, there's no sound. And it's possible because AdLib is on a different IO address and the way they implemented it on this card is different. It's hard to say. So I'm going to give up on that avenue now. If someone has any ideas, just let me know. But for now, we're just going to move on from that. And I think we're going to do some benchmarks. I also want to say, in this machine, I finally got the SD card to recognize. So what I did was, there on a modern version, a modern computer, you can format these SD cards with the SD card formatter tool, which is an official tool. And there's a checkbox that says CHS. I forget what it says. You'll know it when you see it, because it'll say there's a checkbox. It literally says CHS something or another. So I hit that box, and that formatted the card to allow it to be seen by this system. As soon as it loads the driver, I can actually see the card by this computer. So I don't have the mouse hooked up right now. So I can actually look at this particular card. And there it is. And it sees all because it's a 1 gigabyte SD card, it sees the whole thing. Also, just for testing purposes, I started this computer up with the PCMCIA DOS driver, and it sees the full 1 gigabyte card in DOS as well. So yes, you can use these more modern SD cards if you format it with the official tool and click the CHS button. It'll do something funky with how it formats it, and it allows it to work in these old machines. It's better than being stuck with this CF card that just spontaneously died on me while it was transferring those files. Because this is 4 gigabyte, but it only format like 300 megabytes of it. And this is an old Bose thing that I reused. So, alright, let's move on and let's do some benchmark stuff. Alright, now that the camera battery is charged back up, let's do some DOS benchmark stuff. Let's see. Now, I've never used this software before. This is the first time I've actually discovered it, so I don't know how this is going to work, and I've not used it before. So let's see. Let's do the CPU check, see what we got. We have 75 megahertz 486DX4, which is what we expected. 25 megahertz bus clock, 16 KB of cache. So at least we know what we're dealing with on this particular hardware. So let's do, what's system information? Yeah, okay, that's a Norton tool. Now, let's do speed sys. I've seen this in a few videos. Let's see how this works out. So it's performing some calculations now. Oh, looks like we have a year 2000 bug. Well, I know the clock is set right, or at least was. Maybe it's a rollover bug. I'm not sure how that works. There's our new old stock hard drive, which Seems to be working perfectly fine with this hardware. No issues there. Our CPU is testing just a smidge over the DX250, which is about expected. And then, let's see, what's it doing now? Oh yeah, it's testing RAM. So we should get nice fast, and then we fall off hard, which makes sense because we have only 16 kilobytes of cache memory. So yeah, that appears to be working fine. We're gonna escape that because we don't need anything in there. Get out of that. Okay, 3D bench. You know what? Let's go full tilt. Let's do a full benchmark on that. See what we got here. It's actually kind of impressive. I'm shocked. For a 486. Let's see, we've got 33.1. Not terrible, I guess. I'm not sure what would be good for that, but okay, 3D bench. I don't know what PC player is, so let's run that. Oh yeah, I think I remember seeing this. Ooh, she's a little slow. Little pokey. It's doing something down here. 11.7. Yeah, she's a bit slow. Okay, let's really set this thing on fire. Let's do Doom max details. Because this will answer the question, can it run Doom? Well, we shall find out. No sound because I don't have a DOS sound driver. Oh yeah, she's slow. Oh, I guess that's about right for a 486 laptop, I suppose. The screen on this thing is really nice. I don't know how well that's coming across on camera, but it's a nice display. And yes, I do have the original battery. It just needs to be rebuilt, but I'm not going to worry about that thing. Yeah, she's taking a bit to do, so I think we're going to skip ahead here. Well, we have 3605 real ticks with an FPS of 20.72, which is not terrible at max settings. So let's do minimum details. Let's see how that runs. See how, I'm just curious if it does any better, or if it's the same, or I don't know. We'll find out. Oh wow, that's a tiny hole. Tiny viewport. That's not playable. But wow, that's pretty quick though. I think somewhere in the middle would kind of make this machine playable. But yeah, that seems to be running a lot quicker than the last demo. Yeah, 70 frames a second. Yeah, I bet. Okay, Quake Time demo. Let's run that one, because why not? There's a couple different versions. There's D and E. I don't know what all the differences are. I'm assuming resolution. Oh yeah, she's a bit slow. I don't think that would be playable. No, that is not playable. But you know what? Let's check some other ones here. Quit that. Yeah, get out of whatever. So let's do 360 by 480. See how that one runs. That is a no. No, this panel can't do that. That's a fail. Yeah, that failed miserably. Reboot. Okay, had to get out of that. I think this does the same thing. .360 by 480 would probably work if I had an external CRT, you know, but oh yeah, that's the same exact scenario. One thing I've noticed about Quake on this laptop, and it's actually coming through better on camera than it is in real life, is the image is really, really dark. I think my brightness is turned all the way up. It is. The other thing too is you got to make sure your energy settings are turned all the way up to get maximum brightness out of this panel as well. Because by default it runs at like half performance, half power saving, which dims the backlight down a bit. So just keep that in mind. But it seems that Quake does run on it. It's just not very playable. I don't have Quake 2. Quake 2 would likely not run on this thing. Quake 2, it probably needs a Pentium, bare minimum. But honestly though, that's got a pretty good display on it. For 1994, when this laptop came out, that was impressive technology at the time. It really was, because the majority of laptops back then were all passive matrix, or black and white, even worse. And could you imagine trying to play Quake or Doom on a passive matrix display? No, I don't think so. So we're just gonna go ahead and quit this. Get out of that. And I think that's it. Let's try a landmark speed test. Yeah, no, I don't know what it uses for calculating speeds, but that's not right. Anything else in here? What's top bench? No. What else is in there? So, who's a PC player benchmark at 640 by 480? See what happens there. No, didn't work. Nope. You know what? That's right. I need a DOS VESA graphics driver. Again, it's hard to find DOS drivers for this machine. I need a VESA driver for DOS, and I need the sound driver for DOS, but anyways. So that's it for benchmarks. Other than that, this thing seems to be working fine. Let's move on from here. I think this machine is already fully reassembled now. I had to do that off camera because the battery died, and I'm not gonna hold my phone camera while trying to put it back together, because that's just not possible. But yeah, Windows 95 is pretty much sacrilege on this thing, but you know what? Seems to be working okay, at least. I don't have the mouse that goes in the side. Sound works fine in Windows, no problem with that, but I gotta empty the recycling bin because I put a bunch of crap in there. And I think we have the right time. 16 megs of RAM, that's on board. And a card. Yeah, it's got the right time. It's working right. But yeah. And ACPI management works with this thing too, because I can shut it down and it will turn physically off. It is. So it's off. We've done our diagnostics, benchmarking. Everything seems to be working. the exception of finding DOS drivers for this hardware, everything else looks pretty good. I mean, with this nice brand new top cover, I cleaned the original keyboard and it still looks really good. The lid looks brand spanking new, because it is. Even the charger's new. It just sucks that this cable is degraded in such a weird way. I do not have the mouse attachment for this thing, so I had to use an external mouse. And this thing is extremely tight because the lower board assembly is also brand spanking new. So these ports have never been used before. It's all new. This is broken. I don't have that piece there. And I don't have the cover for this either, so I'm going to have to make that. But just the condition of this particular case, I don't know how to save the sticker. But yeah, this looks really, really good. So it looks basically like it came off the factory floor. It did. It came off of my factory floor. So anyways, that's it for this one, guys. If you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. Until next time, guys. Thank you for watching.